Is it recording?
Think so.
Okay.
Yeah, it is.
So, are you eating your dinner as you're doing this? Are you?
Yeah.
Okay. Well, anyway, let's say I've got a piece of cardboard, a sheet of cardboard, 12 by 12. Okay.
Uh-huh.
I'm going to cut a square like this, and from that I can create a box, an open-top box. Okay. So this is like this green area is like the base of the box. So in 3D, it will look like this. That's the base of the box, and then it will look something like this. Can you see this?
Uh-huh.
So when you fold it up, you're going to create a box. Okay.
Okay.
I want to maximize the volume that I can create. So how should I cut it? Because see this length here.
Mm-hmm.
Can you see what's going on? That's this length here. Can you see that?
Okay.
And let's say see this blue length here.
Uh-huh.
It's this length here. You can create a box. Okay.
Okay.
And what's this length here? What's this red length here?
Part of the 90-degree angle?
I don't know what you mean, but this length here is really this height here. Can you see that?
That's what I meant. Yeah.
Okay. So how should I create this box? How should I cut the? But basically, I'm gonna call this X. How should I? What must X be in order to maximize the volume? How do you go about answering this? Do you understand
First
the
you
question?
find out the whole square.
Well, the whole square is 12 by 12.
So
Let's say
144.
Yeah, 144 is the area. But how does that help me find the volume of this box?
I don't know. I just thought it would help or something.
So when you're faced with this, put some numbers in there just so that you can get an understanding of what's going on. So how would you cut this box? Suppose I were to cut it. Let's say I'm going to cut this 2 by 2. Is that okay?
Okay.
So you've got to somehow create a machine where if I put in the number 2, which represents the width there, what must the volume be? So it has to spit out the volume. What's this volume here?
I don't know what number to
Speaking to the microphone. I can't hear you.
I don't know what number to put in.
What do you mean you don't know what number to put in? You got to come up with...
You told me to guess, but I don't know what's a good guess.
I'm saying guess this to be the number 2, just so that you can have an understanding of what's going on. Suppose I were to cut this square out 2 inches by 2 inches. What volume would that create? What would be the volume of that box?
2 times 2.
2 times 2 times 2 would give me
8.
Well, yeah, but it would give me like this small box here, Chelsea. It would give me this small box here. Can you see that? 2 by 2. So this area
the green
here,
length. The green length is 12 minus 2x.
Yeah, but what is it in our case when x equals 2? So hang on. Let me ask you this. Wait. Let me just clear this up. Hang on. I want to know what the height of this box would be when we cut it at 2. Do you understand the question? What's the height of the box if we were to cut it at 2? So I want to know this height here. What's this height here, Chelsea? What's this red height?
2.
Yeah, 2. Okay, and then what's this blue length?
12 minus 2x.
12 minus 2x would then give me this length. I don't want that length.
12 minus 4x.
What x equals? What 12 minus what was it?
4x.
4x. So we're going to put 2 into the x. Is that what you're saying?
No. 12 minus 8.
12 minus 8. So
wait,
12.
Wait, no, let me think.
I just want to know this length because I need to know this length in order to work out the volume.
Yeah, 12 minus 8.
Okay, so I would get this whole length. Okay.
Wait,
no.
12 minus 4.
Yeah, 12 minus 4, which would be 12 minus
8.
4, which would be 8. So this length here is 8. Okay. Yeah, and then what?
Then you find the width.
Yeah,
which is
this?
Also 8.
Yeah. So therefore, you can work out the volume. What volume would that give us?
188.
64 times 2, isn't it? Isn't that?
168.
What?
168.
No.
Oh, 128. Oops.
Yeah. So we spit out a volume of 128. Okay.
Okay.
So what must X be to give me the biggest volume? So let's put a 3 in there to see what's going on. If I put a 3 into there, what volume will it spit out?
Let me think.
Oh, what's this
6?
height though?
6.
6. How do you work that?
3. 3.
Well, we spit out volume of 3, like this. With that. So if I were to cut it 3 by 3, what volume would that give me?
9.
That's the area of this, isn't it? 3 times 3 will give me the area of this. That area doesn't represent the volume of the box.
Wait, let me think. Yeah, I don't know. I thought it was 3.
Yeah, I'm cutting it at a length of 3. So this is 3, and this is also 3. So I'm cutting out that square. But what volume will that give me? If I cut it at 3 and 3, what volume would it give me? What's the volume of the box? If I were to cut it at 3 by 3, I need to know what volume that is. So how do we get from 2 to 128?
We found the length and the height and the width.
Yeah, so why can't you use the same technique?
Well, I was talking about the red line that you highlighted.
Oh, okay. So what's this length here?
3.
Okay. I misunderstood then. So that's 3. And then what's this blue line here?
That one is 6.
That one would be 6. And then what's this thing here?
That one would be 6.
Yeah. So the volume would be 36 times 3, right?
Yes.
18 carry the 1, so it's 108. So
yes.
So far, which would give us a bigger volume? Cutting it at 2 or cutting it at 3?
At 2.
Yeah, but somewhere in between.
If we made it a really, really small number, it would become really big.
Oh, let's try it.
Huh?
Yeah. Shall we try 1?
Yeah.
Okay,
No.
so what would it be?
Try? Yeah. Okay,
Speak into the microphone.
Yeah, okay.
All right, so what's the volume? What's the height?
1.
Yeah. What's this length here?
10.
10. What's this? Well, this would be 10. So
10.
what's the volume? So
10.
what's the volume?
100.
Yeah, so 1 is not bigger than 2. So how should we cut it to give us the biggest volume?
It has to be smaller than 3 but bigger than 2.
So you're saying it's somewhere in between here. How do you know it's not somewhere in between 1 and 2?
That's true.
So what now? And don't forget, we don't always have to cut it with a whole number. We can cut it at 2.6 or whatever.
Can we cut at 2.5?
You see, yeah, we can sit here all day. Why don't we use calculus? Because if you make X to be really big, Chelsea, you're gonna have like a small area, but a really tall box, right?
Okay.
if you cut it, if x is small, you're going to have a big area, but not so tall of a box. Can you see that?
Okay.
So somewhere in between, there's going to be a value of x that will give us the biggest volume. What must that be? How do we find out?
We can call it x and create a formula.
Yeah. So we're going to call this variable x. So x is going to represent the width of our square.
So 12 minus 2x is the length.
Well, what's that again?
12 minus 2x is the length.
Yeah, 12 minus 2x. And then what's this then?
12 minus 2x.
12 minus 2x. How come you're not eating your dinner then?
I am.
Are you? Okay, what's this height here?
X.
Yeah, so basically now you've got v as a function of x, meaning x is what you put into the machine, and I want to get the volume out for that given x equals what?
12 minus 2x times 12 minus 2x times x.
Yeah, so that would be x, and then 12 minus 2x squared, like this, right?
Yes.
Yeah.
No. Yes. No. Yeah. Yes.
Yeah, because it's just this thing times this thing times this thing. These two are exactly the same, so let's just square it. Is that okay?
Yes.
Can you multiply this out so it looks neater? What does that become?
That would be 4x.
Wait. Yeah. Hang on. At the back of your mind. Well, what? 4x and then what? Is it 4x?
4x squared.
Yeah. Hang on. Let's do it systematically. Otherwise, we're going to lose track. Okay. So it's going to be
4 plus 4x
times this, and
plus
then this
4x plus 144.
Oh, okay. What will it be? Let's start again here.
4x squared.
4x squared
plus 4x
plus.
Wait.
What?
4x.
Are you thinking?
20x.
20x.
24x.
Sorry?
24.
No. Wait.
Wait, hold on. Negative 24x minus.
Chelsea, let's do this systematically. Let's do 12 times 12, and then 12 times
20.
What?
20x.
No, all right. Let's do this systematically. What's 12 times 12?
144.
144, and then 12 times negative 2x.
Negative 24x.
Yeah, negative 24x, and then negative 2x times 12.
Negative 24x.
Negative 24x, and then this
minus 24x.
No, it's positive. Two negatives, isn't it?
No, where? Oh, yeah, I didn't see that.
So plus what?
Plus 24x.
Hey, you got to do this time. Oh,
4. I meant 4.
4. For what?
X.
No, what's minus 2x times minus 2x?
Positive 4x squared.
Yeah, positive 4x squared. Okay. And now what? See the middle two terms? You can merge them together. What would that give us?
48.
144, take away 48.
Negative 48x.
What am I doing? Negative 48x plus 4x squared. And then what?
Put the 4x squared to the top so it makes it neater. Nicer.
What do you mean?
So it looks like 4x squared minus 48x plus 144.
I don't know what you mean. Let's get this times this times this, and this times this. Is that okay?
144x
144x
minus 48x squared
minus 48x squared. And then what?
plus 4x to the power of 3.
Yeah. Is this what you meant earlier, where you put this in front? So it looks nice.
Mm-hmm.
All right. Okay, so it becomes 4x to the power of 3 plus 144x minus 48x squared. I've got to put the squared first, don't I?
Yeah.
Okay. Minus 48x squared plus 144x. So that's V. Okay?
Okay.
So what now? How did you answer the question?
Let's see. So we found this, right?
No.
Oh.
So when will it
So what did we just find? Just the volume?
Well, what you found here is for any value of x, you can work out the volume. That's what we found with this formula. You see, when you say, oh, let x equals 2, you now have the ability to work out the volume straight away by using this formula. Right? Yay or nay?
Wait, let me think. Oh, okay.
Yeah, so all you found with this formula is that you now have the ability to work out the volume of that box for any given value of x. So if you were to say, oh, let x equals 3, we can work out the volume straight away just by plugging x into the formula. You see that?
Okay.
So what now? How are we going to answer the question? Oh, wait. What's the domain for our situation?
It cannot be.
Can x be anything? Can x be 100?
X cannot be greater than 3.
X cannot be greater than 3. I think it can be 4. Let's try and make x to be 4. So zoom into that square. Chelsea?
Okay.
I'm saying x can be 4 and 4.
Okay.
Okay?
Okay.
So what's the height of that box?
4.
4. What's this length here?
2.
Hang on, let me think. 4 or 8. No.
4.
Yeah, it would be 4.
4.
And this would be 4.
4.
So when it's 4, it will speak out a volume of 16 times 4.
62? 64?
64, yeah. It would be 64. Not a big volume, but it is. So 4 is allowed. You said that the domain.
It cannot be. X cannot be a negative. No, x must be a real number.
Okay, I'm not going to put a complex number. Fair enough. And then what?
What do you mean? Then what? That's the
so
thing.
you can say. So you're saying I can put any number in there as long as it cannot be a.
As long as it's a real number.
Okay, then I'll put 1,000,000 in there. Then that's going to be. What happens if I put -3 in there? That doesn't make sense. How can I cut it at a length of -3?
Oh, x cannot be negative.
Oh, so you're saying. So hang on, where can I write now? So you're saying domain. ... x can be anything on the real number line, comma what?
Cannot be negative.
Cannot be negative. So can I put any
X
number
is greater than or equal to 0.
Can it be dead on 0?
Yes.
Okay, so let's make this to be 0 then. Instead of the 4, I'm going to cut square of
No.
0. So the height
equals 0.
Yeah. So it must be strictly greater than 0. Do you agree?
Yes.
So you're saying the domain is that I can't put a complex number in there, and I can't put a negative, but I can put any number greater than 0, right?
Okay.
So let's make it 100. I'm going to cut it 100. So what volume would that give me? Speaking to the microphone, Chelsea. What volume would that give me if I cut it?
Let me think. $100 times 100 is
What?
10,000, right?
Hang on, I'm going to cut it
1,000.
What's the height? What's this red height here, Chelsea?
100.
What? Yeah, 100. What? What?
It cannot be a big number because then.
Oh, what's big?
Wait, it can't be 100 because.
All right, cut out 50 then.
It has to be. It has to be less than 12.
Yeah. Right. So yeah, I can't put 100 in there. It doesn't make sense because my sheet of paper is only 12 by 12, right? So let's cut it at 10 then. Is that okay?
At what?
At 10 by 10. So if I cut it by 10 by 10, what's this length here?
10.
What's this length here?
It cannot be 10. Has to be less. But let me think. Let me think of the domain. Has to be less than 12 or less than 6.
It has to be less than 6. Yeah. Can it be dead on 6?
No.
Correct. Okay. Yeah, if you cut it 6 by 6, you're not going to be able to form your box. Anyway, so the domain is strictly greater than 0 and has to be strictly less than 6. That's your domain there. You see that?
Yeah.
So now really what you want to do is you want to draw a graph of the volume versus x. You see that, Chelsea? And your domain is from 0 to 6. So you don't really care what the graph looks like beyond 6 and negative. You see that?
Okay.
So what does that graph look like?
It looks like a variation.
What? Years and years ago, I asked you to sketch this. Let's say y equals. We did this years and years ago.
When it's a big number, it wants to do x to the power of 3.
Yeah. When it's big. Oh, okay. Let me test you out on this. 1 over x plus x squared. What does this look like?
When it's a really big number, it wants to do x squared.
Yeah. So it wants to do x squared like this, but only when it's big.
When it's small, it wants to be
1 over x looks like this, Chelsea. Right? When it's small, 1 over x dominates. You see that? So as a result, your graph will look something like this.
Yes.
Remember that?
Yes, I do.
So use the same technique for this. When it's big, it wants to do x to the power of 3. Can you see that?
Small, it wants to do.
It wants to do this straight line here.
Yes.
Okay. What's the intercept of our graph?
144.
No.
No. 0.
Yeah, 0. So what does this line look like?
A straight line.
Yeah, very steep or shallow?
Very shallow. No,
like this.
Very steep.
Yeah, because if you have a gradient.
I forgot. I was looking at the y-axis.
Okay. So I know it should be a lot steeper, but we're just sketching it. Let's just imagine it to be something like this. Okay. So it's a straight line going through the origin. It wants to do a bit of a negative quadratic. So let's turn it around slightly like this. Something like that. Yeah?
Okay.
And then when it's big, it wants to do the cubic. So it wants to do something like this, only when it's big. So meaning it must want to do something like this and this. You see that?
Yes.
So what do you think your graph will look like? But so I'm going to make this really steep, and then it has a tiny bit of a quadratic, a negative quadratic. So I'm going to make it curve down like this, as opposed to curling up. That would be a positive quadratic. Can you see that?
Okay.
And when it's big, it wants to do the cubic like this. So what do you think? Zoom out slightly, Chelsea. Okay, what do you think your graph will look like?
Like this.
It has to do a cubic. Yeah, it has to do a cubic, and it has to pass through that line. So your graph will look something like this. Okay.
Mm-hmm. Yeah.
So what part are you interested in? Let me just erase everything and then redraw this. So as it turns out, you can always jump to decimals and sketch this graph, but it will look something like this. I don't know what it looks like. Something like this. Hang on, let me just. I don't know precisely, but I know that it looks something like this. I don't know what it looks like. Some similar to that. Okay.
Okay.
Okay. Now what? What part are we interested in? Actually, jump to decimals. Let's see what it truly looks like. So punch this into Desi. 4x to the power of 3. Yeah. Minus 48x squared. Plus 144x. Yeah, so that's what it looks like. You see, for volume, don't forget we had a volume of 128, didn't we? So that's what our graph looks like. Do you know how to make the graph look nicer?
I think so.
Go to the spanner, change the axis. The spanner, the wrench, as you guys would call it.
Oh, the wrench.
Yeah. Okay. X. Yeah. Let's make it range from 0 to
10.
6. But don't forget our domain is only from 0 to 6, isn't it? Yeah, you can do it from 0 to 10 if you want. But what's really relevant to us from 0 to 6? Oh, all right. You changed the height. Did you change the height, or did it do it automatically? And anyway, no, that's good. That's a good height. Oh, leave the height. It's quite good.
Well,
Anyway,
too bad.
what are we interested in, Chelsea?
The X.
Right? How come your graph looks rubbish now? Okay, what part are we interested in?
This part.
Yeah, the highest part. Oh, well, why not at 10? 10's quite high.
Because
if you want
we're
to
on a limit of 6.
Oh, we're in the domain of 6, right?
Yeah.
Yeah. Okay. Yeah. So what's the answer then? What's the value of x that will give us the biggest volume?
Two.
It looks like it, but we don't know for sure, do we?
It says 2, 128.
Yeah, but don't forget, is that really truly the top of the graph?
Yes.
You know that for sure? Would you bet all your money on it?
Yes.
You don't know for sure, though, do you, Chelsea? You have to differentiate it and find out where the gradient is 0, don't you?
Okay.
It might be 1.99999926. You don't know. It's definitely dead on 2, do you?
No.
So you got to jump back to iDrew and differentiate it. Find out where the gradient will be 0, because that's the highest point, isn't it?
So the first thing would be 12x squared.
Yeah. So we're going to differentiate it. So when you differentiate this, it would be, what do I write here, by the way, Chelsea? If I were to differentiate it,
dy by dv by dx.
Yeah. Or I can write v prime x if I want to. But
Okay.
dv by dx. dv by dx. So that represents a gradient. So that would be what? Oh, yeah, that would be what?
12x squared
12x squared
minus 96x squared.
96x, because the power gets minus by 1.
Oops. Plus 144.
Yeah. 144. Now what?
I thought we've already. Didn't we just differentiate now?
Yeah. So now what? What's the answer? That doesn't really tell us the answer, does it? I want to know what value of x should I cut the square in order to maximize the volume. This one here, the answer. We're not there yet. We need to find a value of x. What now? Because ultimately you want to find out this point here, Chelsea, the highest point.
I'm not sure.
Well, what's so special about the highest point? This is what the point that you're trying to find. At the highest point, the gradient would be what?
0. Oh, so you put 0 into the...
into the dv by dx. So put 0 into that, because you're trying to seek a value of x where the gradient would be 0, because the gradient of 0 would mean you're at the top of this graph.
Yes.
Okay?
So,
by the way, gradient of 0 could indicate there as well, but we don't really care about that, right?
okay.
So we're only interested in the domain where it's less than 6. Anyway, what now?
Subtract 144.
Well, this is a
single.
this is factor. So you can't
factor.
simply make x the subject. Wait. You notice that all these, they're all even, so you can simplify this.
Oh, divide by 12.
Divide everything. Oh, how do you know that's divisible by 12? You could be right. Is 96 divisible by 12?
Yes, by 8 times 12 is 96.
Okay, so divide everything by 12.
So then it would be x squared minus 8x
minus 8x
plus 12.
Plus 12. Yeah, this is much neater. Now what?
Factor.
Yeah. How do you factorize this?
X, both sides.
Yeah.
Minus, let me think now. 8, 2, 10. I'm thinking. Hold on. I'm not sure what's multiplied to get 8 would equal 12.
Okay. Well, when you factorize, your biggest clue is this thing here. You know you're going to get this times this, right?
Yes.
So two numbers multiplied together to give you 12. It could be a 1 and a 12. It could be a 6 and a 2.
Oh, 6 and 2. Yeah, I did that wrong. I messed up by accident. 6 and 2.
Okay, so 6 and 2 would then give you this. You can create an 8 with that 6 and a 2. Can you see that? But bear in mind that it must be a negative 8. So anyway, what goes in here and what goes in here?
Plus 6.
Plus 6.
Minus 2.
Minus 2. Okay, let's multiply this out. Will it give you negative 8?
Wait, no. Minus 6 minus 2.
Yeah, it has to be a minus and a minus in order to create a negative 8. Can you see that?
Uh-huh. Yeah,
so,
I do.
So to factorize this is that. Okay, now what? Wait for Santa.
Now you put in the solutions. So x minus 6 equals 0.
Yeah, what about it? So x minus 6, so x equals 6?
Yes. And then the other one, x minus 2 X equals 2.
Yeah, x equals 2. So which one do we use? There are two solutions.
You try the 6 out and see if it's bigger than the 2.
Wait there. If you go back to what's the domain for our situation? Earlier I asked you for the domain. What's the domain for our situation? What's the domain?
Oh, it's going to be 2 because it cannot be 6.
Yeah, so that's 6. It's useless, right? Well, by the way, that's 6 there, Chelsea. That's this turning point here, where the gradient will be 0. Can you see that? But it turns out that 6 is beyond our domain. And that 2 there is another place where the gradient is 0, which happens to be the highest point.
Yes.
So you were right years and years ago when you said it was 7.2 when you looked at decimals.
I said I would lose all my money for it, and I won. So.
You can't be sure though, can you? It could be 1.9999 and then decimals rounded off to 2. So for this, you can actually see it can never be 1.99999 and so on. Okay, so it turns out to be 2. Really?
Yes.
Okay, so next one. Okay?
Okay.
All right, so we've got, hang on, let me think. Oh yeah, before we, let me set you the problem first. Let me just zoom into 100%. You might have to look around for me. We've got to design a cylinder.
No.
What? You don't even know the problem. You're crying already. We've got to design a cylinder where we'll hold a volume of 1 liter. Okay.
Okay.
And we need to minimize the amount of material, the amount of metal needed to make this cylinder. Right? You understand? So so you can make a fat cylinder like this, but it has to be short. You see that?
Okay.
But it has to hold 1 liter. Or you can make a really thin cylinder, but really tall. You see that?
Okay.
But I need to minimize the amount of metal needed to make the cylinder. So the amount of metal is that you've got this circle at the top, circle at the bottom, and you've got this sheet right in the middle. Can you see that? I want to minimize the material needed to make that cylinder. So how should I frame my cylinder?
To make this cylinder in the middle or the cylinder in red?
No, the volume of the cylinder must be 1 liter. So what radius must I create my cylinder and what's the height? Can you see that, Chelsea?
Oh, jeez.
You have to give me the radius and the height. That must have a volume of 1 liter, and it must minimize the amount of metal needed. So what's the amount of metal needed then, Chelsea? Hang on, let's start again. Hang on. So if I were to give you a cylinder here like this, and the radius is r, the height is h. Okay, Chelsea. What's the amount of material needed to create this? By the way, I'm actually when I say the amount of material needed, I'm actually talking about the what, you know?
The volume?
No, the volume doesn't translate to the amount of material needed to build that cylinder. The volume is the wrong thing to look at. I mean, should I be looking at the circumference? Does that represent the amount of material needed?
I don't understand what it means what material needed.
All right, if you were to build this cylinder, you in order to build this cylinder, you see you've got to create.
You need the area of the circle and the height of the circle.
What height? How can a circle have a height?
The height of the cylinder.
Okay, the height is, let's say the height is 10 centimeters. Height is like a length, it's like a piece of string. That doesn't tell me the amount of metal I need in order to build this cylinder. Can you see? that sheet of paper and that sheet of metal in the middle, Chelsea, it's like this, Chelsea. You can roll it up to form a cylinder. You see that? Imagine you've got a sheet of A4 paper. You can roll it up like this, Chelsea, to form a cylinder. You see that?
Yes.
Yeah. Anyway, I'm actually after the surface area. That tells me the amount of metal I need. The bigger the surface area, the more metal I will need. Do you agree with that?
Okay.
Do you agree with that? Yay or nay? Because
I don't understand.
Okay, if you were to build a box, okay, Chelsea. To build this box, you will need this sheet of metal here at the top. Do you agree?
Okay, yeah.
And you will need another sheet at the bottom to create your box. Can you see that? The green sheet of metal at the bottom. Can you see that? And then you also need the sheet of metal around the outside here, like this. Can you see that? That's four of them. Two at the back as well. Basically, you're looking at the surface area. Do you agree?
Okay.
The surface area represents the amount of metal you will need in order to build that box. Yay or nay?
Okay, yay.
Okay, wait there. Suppose I were to build this box here. This is hang on. So the height is not to scale. Okay, the height is 1. This is 2, and this is 3. How much metal do I need in order to build this box?
6.
6. Not. Okay. In order to build this box, I need this sheet of metal here. Can you see that at the top? Do you agree?
Yeah. Wait, let me think.
I will need another sheet at the bottom as well.
36.
What?
36?
No.
36. Wait, let me think.
Let's build this box, Chelsea.
Oh my gosh! I can't imagine it.
What? It's like a box, and I want to know how much metal I will need in order to build that box. Okay, can I ask you this, Chelsea?
I'm confused.
Okay, how much metal do I need in order to build the top of this box? How big of a piece of that metal do I need in order to build that box? Well, can you see it has to be 2 times 3?
6.
So I need an area of 6, right?
Okay.
Do you agree?
And
I will need another sheet at the bottom of that box for the base. Can you see that, Chelsea? The base at the bottom, this green area here. Speaking to the microphone, Chelsea.
Yes.
All right.
Yes.
So what's the area of that green base?
6.
Chelsea. Yeah, it's also 6 because you got the top and the base. Do you agree?
Okay.
And then now I've got this long sheet of metal here. What's this area here?
3.
3. Yeah, 3 times 1, isn't it? Which will be 3. But then there's another one over here, isn't there? So I'm going to times it by 2. Are you okay with that?
Okay.
What else do I need?
2. And another 2.
Yeah, so I need this, let me choose another color. I need this purple area here. Can you see that? Around the back. So that would be 2 times 1. Can you see that? So how much metal do I need altogether? I need 6, and 2 lots of 3, and 2 lots of 2. So how much metal do I need altogether?
Let me think. 12.
Yeah, so this will be 12.
Plus 9.
Why 9? Why 9? Why 9?
3 times 3 is 9.
Why 3 times 3?
Because you said 2 times 3.
Yeah, 2 times 3 is 6.
Oh, oops. 12 plus 6 plus 4.
Yeah.
22.
Yeah. So I need a piece of metal where the area is 22. Right?
Uh-huh.
Can you see what you've just worked out? The amount of metal you need is actually the surface area. What you just worked out is the surface area, Chelsea.
Surface area? What was...
The surface area is the area on a surface of a box. If you have a box, have you not done surface area in school?
I don't... Maybe I have, but I just don't remember.
Okay. If you have a box, what's the surface area? Surface area is like the area on the surface. So wait there, Chelsea. Let me give you
Oh, yes, I have done it.
Yeah. So let's say this is A, B, and the height is C. Okay, what's the surface area? So surface equals what?
A.
Right. What's this area here?
ABC.
No, that's a volume.
AB.
A times B. Oh, yeah. Okay. This purple area here is AB, right?
Uh-huh.
But then you got the one at the bottom as well. So can I just call it 2AB?
Yes.
Okay. What's this red area here?
BC.
Yeah. And then you got another one at the back. So it's 2BC. And then what's the other one? Plus what? What's this green one here?
AC.
Yeah. And that's your surface area, right?
Okay.
Right. What about the one
2AC.
Yeah. So that's your surface area. It's really the area on a surface, isn't it?
Yes.
What's Oh, okay. Let me give you this then. Hang on. Let me clear this. So the surface area really represents the amount of material you would need in order to build your box. Let's say you've got a cube here, like a die, and this is X and X. What's the volume of this? The height is also X. What's the volume?
X to the power of 3.
Yeah. Okay. That's the volume. What's the surface area?
2x plus
Plus what?
plus 2x squared
Like this?
plus
Oh, wait. Did you mean
2.
2x here, Chelsea?
Huh?
Did you mean 2x here?
No.
So what do you mean? What
Right
is
there. 2x.
it? What?
Oh, I just lost connection.
Okay. All right. Let's start again. What is the surface area, Chelsea? Let's start again. I'm confused. What's the surface area, Chelsea?
X squared.
Yeah.
Wait, let me think. X squared plus 2x squared.
Well, wait. Start again. Hang on. X squared plus 2x squared, like this. Is that what you're saying?
Yes.
Okay. Why x squared, by the way, and why 2x squared?
Oh shoot. Okay, delete that. Delete all of it. I need to think. The X's are making me confused.
What? All right. If you're gonna cry about it, let's call it A then. Are you happy now?
No, that's not better.
What do you want to call it?
Call it a number, not a letter.
Oh, what? Okay, 3.
Okay.
What now?
2 parentheses 3.
Yeah. And then what?
I'm thinking 2 parentheses 3 times 2 or 3 plus
Oh, let's just revert back to X, Chelsea. Wait, I'll show you how to do this.
Well, I know how to do it. It's confusing me. If it was different numbers, I think I would be fine.
Do that. What's this area here?
X squared.
Okay, x squared. That's the area there. And because it's like a die where everything's the same, there are 6 sides on this cube. So it's just 6x squared. There, that's your answer.
What?
What? This thing here represents one face, right?
Oh, and there's
You see,
6.
you see this
Oh, yeah. My head is
this
going blank because I don't like math. So.
well, this die is a bit like you, isn't it? You have 2 faces. This one has 6 faces.
Okay.
So this one here, Chelsea, the area here is like x squared is the area, and there are 6 of them. So you just multiply by 6. Okay, let me give you another one. So that's the surface area, right, Chelsea?
Okay. Yeah.
Okay, if I were to give you this here, this rod, this metal rod, let's say this is x, and the length here is y. What's the surface area now? Wait, what's the volume first? What's V?
X squared y.
Yeah, x squared y. Okay, what's the surface area?
2x, 4x plus 2y.
4x plus what? How do you get 4x?
Wait, no. Let me think. Just let me think. Okay. X squared, 2x squared.
Yeah, 2x squared. So that's
plus...
this face. And that's this. That's these 2 faces. So it's 2x squared done. What about the
2xy?
y only 2?
Or 4xy, I mean.
Yeah, plus 4xy. You see, the surface area can also represent the amount of metal you will need to build this rod. Because if I were to ask you, how much metal do you need to build this rod? You would say, oh, I need this sheet of metal. You see that?
Uh-huh.
And there's going to be 4 of them. So you times it by 4. And then you're going to say, oh, to build the side of the box, I need this amount of metal, which is x squared. And there's another one at the back. So the surface area and the amount of metal go hand in hand. They're on par with each other. So me asking you how much metal you need is really me asking you for the surface area. Do you agree?
Okay. Yes, I do.
Yay or nay?
Yay.
All right. So back to the cylinder.
I've learned surface area. It's just I forgot about it.
Okay, it doesn't matter. Okay, so what's the surface area of a cylinder? We've actually done this years and years and years ago. So wait there. Surface area of the cylinder, Chelsea. Can you see you need 2 circles at the top of the cylinder?
2r squared.
What? Say that again.
2r. No,
2
that's just the radius. 2 pi r squared.
2 pi r squared. Yeah, so this area is pi r squared. This area is also pi r squared. Now the hard part. What's this metal? You've got the you know, if you've got it.
4h.
Well, wait, Chelsea, if you have a cylinder and you get a knife and cut it down the middle, you can lay it flat on a sheet on a table, and then it will form a sheet of paper.
Okay.
Do you agree?
Okay.
What's this green length here? Chelsea?
H.
Yeah, H. What's this blue length here?
H.
No. You see that blue length, Chelsea, is really this length here. Can you see that?
Oh. 2 pi r.
Yeah, 2 pi r. So so what's the surface area of a cylinder? Surface equals what?
Surface equals 2 pi r.
2 pi r. 2 pi r.
2 pi r squared.
Oh yeah, because that's like 2 circles, isn't it?
Plus
the sheet, the metal, the middle sheet. What's that area?
2 pi r h.
2 pi r h. Yeah, that's your surface area.
Yes.
Okay, Chelsea.
Yes.
So how do we go about? Oh yeah, I asked you. We've got to create a cylinder containing one liter. Okay, Chelsea.
Okay.
What can you picture what 1 liter is? What is 1 liter? I mean, you can picture a cube like this, 1 centimeter by 1 centimeter by 1 centimeter, right? Imagine this is like water here. If I have 1 centimeter, 1 centimeter, 1 centimeter water, how many of these cubes can I fit in here? Do you know what 1 liter is, Chelsea?
Yes.
How many of those cubes can I fit in that cylinder?
I don't know. What the hell?
1 liter. Can you not ask Google?
What do you want me to ask?
How convert 1 liter into centimeters cubed?
Alexa, convert 1 liter into centimeters cube.
How many? What's the answer?
They said, Alexa said, it's not measurable for liquid type. Goodbye.
Anyway, it turns out to be 1,000 centimeters cubed. Okay, that's what 1 liter is, Chelsea.
Okay.
Okay, so what that means is you can fit 1,000 of these small cubes into this container. Okay. And can you picture what this looks like in terms of cubes, in terms of these small cubes? What that means, Chelsea, is you see at the moment it's 1 by 1 by 1.
Yeah.
If you have 10 by 10 by 10, Chelsea, you're going to have 1,000 of those cubes in there. Can you see that, Chelsea? Because look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in here. Can you see you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here, whatever. And can you see, you've got your cube here, Chelsea. That's one of your cubes here. Can you see that? Can you see that red cube? That red cube there is this cube here, right?
Okay.
And when you have 10 by 10, you're going to form that cube, that big cube. Can you see that?
Okay.
Just not drawn to scale, but this is actually 1 liter. That's what 1 liter is. When you buy milk, you buy milk?
Yes.
When you buy a big carton, what's the volume on that? You know?
No, I don't.
You don't have a look at it?
No.
Well, I think 1 liter is actually, you can imagine it as like 10 by 10 by 10 centimeters. That's 1 liter. Okay, Chelsea?
Okay.
How many of these cubes are there in here, Chelsea? So you see that? Do you see this cube here, Chelsea?
1,000.
Yeah, it's 1,000 in there.
Yeah, I was just doing the math.
Yeah, Chelsea, along here, Chelsea, there's going to be like 10 of them. Can you see that, Chelsea?
Okay, yeah.
And then you got another one on top. That's going to be another 10 cubes, so that will give you 20. Can you see that?
Uh-huh.
And then another layer will give you 30. Can you see that, Chelsea? Another layer will give you, basically overall, that one layer there will give you 100, right? Cubes. But then as you extend it over here, Chelsea, can you see you got 200 now?
Yeah.
Yeah, because all along here you're going to have 200, and then another layer would be 300.
You're going to do that for 10 times?
Yeah, that's why that's why 100 times 10 will give you 1,000. That's why you've got 1,000 of those small cubes in there.
Okay.
And that is 1 liter. Okay.
Okay.
So when you go to a supermarket and you see a container saying, "Oh, that's one liter," that's a 1 liter container. It's really 1,000 of these cubes in there. Okay, Chelsea. See you next week.
Okay.
Can you save it for me, please? And you don't need to email it to me, or do you? No, I'm just going to upload it from Skype. It's okay.
No, I'll just send it to you. Okay.
Okay. Thank you, Chelsea. See you next week. Okay.
See you.
I'll send you the homework. Okay, Chelsea.
Okay. Okay.
Bye-bye.
Bye.